Hey there, everybody, my physics friends. I'm so glad to see you. My name is Sean Lally. Physics is my business, and I would like to welcome you to physics. This is a course about the nature of the physical universe. I really, truly hope you love it as much as I do. So, what can we talk about? Well, let me tell you first of all what I think physics is. Obviously, it's an incredibly rich subject, just like anything worth studying. But the thing I love about physics so much is that it covers the fantastically tiny electrons, neutrinos, maybe strings if they exist, to the unfathomably huge galaxies, nebula, the entire universe. It goes from the smallest of the small to the biggest of the big, from the slowest of the slow to the absolute fastest speed that exists. But what it's not just a collection of facts and equations. It's not that. I mean, equations and facts are important. But I think at its purest, physics is a philosophy. It is a method of how to treat a huge variety of problems. Some you've never thought about, some you've never cared about, some you may never think about or care about. But it is a way of approaching kind of strange problems that are all about the nature of the physical universe, the nature of physical reality itself. Now, the actual word physics derives from the ancient Greek word physiki, that is, of course, the English spelling of it. It would be spelled in Greek letters, obviously, but this word physiki meant the study of knowledge, of a particular type of knowledge of nature, physis, and from that we get the word physics. But there's more. The actual physics that we talk about here, the physics that most people study, is the kind of physics that sort of gets its legs by the end of the scientific revolution. The scientific revolution is this period that's roughly 150 years. It's sort of on the heels of the Renaissance in Europe, and it is roughly from, let's say, 1550 to 1700. The reason why those years are usually chosen is because it's around that time, 1550, that Copernicus publishes his first work that puts the sun at the center of the universe, which of course is not exactly true, but it was a lot truer than putting the Earth at the center of the universe. And also, there is a book by William Harvey where he talks about the circulation of the blood that comes about in this period of time. So, 1550, virtually nobody believed that the Earth went around the sun. By 1700, everybody, more or less, believed that the Earth went around the sun. So something happens during these 150 years that we now call the scientific revolution. It's sort of a 20th century term. But something happens during this period that changes how we think about the universe. It changes how we think about our place in nature. We're no longer sort of at the privileged center of things, but rather we are part of it. We're part of the entire universe. So to me, that's what physics is. It's really science applied to the physical universe, but it's a particular type of knowledge that's demonstrated through experiment and evidence and mathematical proof. Yes, physics is a mathematical science. That's the language that we use. Of course, I just think physics is awesome. So here's some of the things that we're going to be studying this term. We're going to look at, first of all, SI units and measurement, how we measure things, why we measure things, why we use standards. We'll look at one-dimensional motion. That's also known as kinematics. We will talk about forces and Newton's laws, gravitation, Kepler's laws, how things orbit, where gravity comes from, energy, periodic motion, waves, sound and waves in general, electromagnetic waves, electrostatics, that is static electricity, circuits, how circuits work, light and optics, and if we have time for, we'll even get into the wonderful world of magnetism. So, if you're at home, you should have a kit, plenty of stuff in your kit. These are a few of the things that you will see there, but some other stuff has been added as well. Let me just tell you a little bit who I happen to be. I, of course, Sean Lally. I am your physics instructor. I've taught astronomy, engineering, science and pseudoscience, science and religion, optics, the history of science, a whole lot of other things. My degrees are from Penn State and Pitt. I've taught at, I've taught at Genesee Park School, many community colleges, Johns Hopkins, Towson University, Duquesne University, and, geez Louise, a whole host of other places in Baltimore and Pittsburgh. I am thrilled to be with you for this course. Okay, I would like to just say a few words about taking notes in a science class. This is the kind of thing that most people probably don't spend a whole lot of time thinking of, but I do kind of think it's important, especially if you're going to go on to take more science classes, or if you are going to do something as wonderful as study science in college. These are things that I have found work for me, so just take it with a grain of salt, but these are based on my experiences. So first of all, when you're taking notes, use a notebook. Use a bound notebook. That's the kind that does not come apart. Not a spiral bound notebook, but rather sort of a, sometimes called a composition book. You can find them at an office store. I prefer quad paper notebooks. That's the ones with graph paper in them. Either that or completely blank notebooks. I've always found those have to be ordered online, but I'm really, really fond of those because, well, geez Louise, I don't need somebody giving me lines where I have to draw, and I like to be able to kind of change the size of my text to fit the situation. So, but definitely I think you should use a bound notebook, one that will never fall apart when you shove it in a backpack day after day. You want to use a new page for every new class and new topic and new date. And write on only one side of the page. Whether you use pen or pencil, I think it's important to write on only one side of the page. There's lots of reasons for that, especially if you use pen, because that'll bleed through often to the other side. You definitely want to give each new page a heading and a date. Another reason why you might only want to use one side of a page is because if later you go back in your notes and you start looking and realize you forgot something, or you want to add some extra examples, you've got the whole other side of the page to do that. So think about that. Use color to highlight any central concepts. Let's see. Oh, highlighters I think are a great thing. Colored pencils, colored pens, any of that stuff. But definitely put boxes around important ideas, important equations. Highlighters, again, always your friend. Oops, sorry about that. Draw pictures that represent the problem, always. And that could be something as simple as if you are dropping an object in a problem, draw a little circle for the ball, maybe draw a hand, anything, and then an arrow that represents the height that you're dropping it from, or anything that is useful to you, especially if you're a visual type of thinker. Maybe if you want to put the labels in there, use the letters that represent things like time. You can even draw a little stopwatch if you want to make sure that you understand what T represents. Anything that works for you, but definitely use the symbols that we use in physics. Use the correct letters, whether it's D for distance or T for time, F for force, A for acceleration, V for velocity, etc. Now, here's a controversial one. Unless it's truly necessary for your learning, that is, unless you are, say, dysgraphic or maybe even dyslexic, I don't really recommend you use a laptop to take notes. You tend to spend a whole lot of time getting down maybe sort of the mundane, trivial even details, and you obviously miss, you occasionally, or sometimes all the time, miss something critical. Boy, that was clumsy. It's also way too tedious to use a laptop to type out equations. Even really, I mean, if you have a touch screen, I guess that's a little bit different, but for the most part, the average laptop is pretty difficult to take physics notes on, especially when you have to throw in graphs and calculations and derivations and proofs and anything that demands visual representation. So, take it with a grain of salt, but I don't recommend you use a laptop for that, unless, again, you are willing to commit to some way to actually write down physical notes for equations, etc. I think it's a good idea to keep a running page of important equations or ideas, maybe even on the inside cover of a notebook. By the way, I would also like to point out with the laptop thing, it's hard to kind of know how to keep good notes on a laptop. The temptation is to start a new document every single time you start a day, and that's a little bit much. Or maybe if you use one large document for everything, again, I think it just is not the best platform. And the evidence backs me up on this. The best way generally to learn a topic and taking notes on a new topic is by writing stuff down. It's just our brains tend to work better that way. Okay, back to the list. Again, keep a running page of the important equations or ideas, maybe even on the inside cover of your notebook. Label formulas with what each variable represents, as well as the units. So when you see something like F equals ma, make sure you write down F is force in the units of newtons, m is mass in the units of kilograms, and a is acceleration in the units of meters per second, or meters per second squared. More about that to come soon. Now, if things are moving too quickly in a class and you don't feel comfortable maybe asking questions, especially if you get lost, Leave space for omitted notes, and maybe with a heading of what that topic is that you're missing some stuff on. And then touch base with the teacher, with me, or the classmate to fill in the gaps. In fact, in general, leave space in your notes. Don't cram stuff all together. There's not a shortage of paper. Write big, space things out. Use lines, use boxes, use color. And again, write on only one side of the page. I think that's the best way to take technical notes. Now, if you have questions and you don't want to ask them in class, or maybe you see that we've moved beyond that point already and you don't want to revisit it at the moment, write down the questions. Write them in the margin of your notes, circle it, but always get your question answered. Seek out the answer after class or by email or anything that works for you. Now, if you have to take notes on a laptop, if that's really important for your learning style, take images of a board, whether it happens to be if you're actually sitting in a class and the teacher is writing, if I'm writing on the board, you can take pictures if you want to, incorporate those into your notes. Or you could always ask me to do a screenshot of something if I'm writing it on the screen. Screenshot, and then I can attach it either as a document to you, or I can just put it in the slides. I usually tend to do that anyway, because by and large, if it's on the board, it probably is in need of being written down. You should write it down. Personally, if I think it's important, I write it down on the board. Once again, never be shy about asking for extra help, even if you want me to take a look at your notes, because honestly, sometimes I can tell if you went wrong just by looking at your notes. And honestly, I think the most important thing to remember is that I am on your side, friends. So again, I'm Sean Lally, Physics is my business, and I am here to help you learn physics. Okay? All right, see you soon. See you on the moon.